was the cube? Gonna get the
All right. So we are live. And so I'm just to set everyone's expectations. I am not good at this live streaming thing. There's going to be some learning along the way here. But we are here to go through myself, Steve Morowski, my coworker here, Josh Duffney. We are going to go through week 2 of Cloud Native New Year, talking about some Kubernetes fundamentals. Now, if you haven't seen, if you haven't seen the blog posts and stuff, then I'm kind of surprised that you'd actually be here. But you can find those at azure.github.io/cloud-native-new-year, or much simpler, you can go to aka.ms/cnny, and that will take you here. And there's a series of blog posts. We're going to be covering the week 2 content, the Kubernetes fundamentals. And with that, let's dig in. If you have any questions, feel free to throw them in chat. Otherwise, we're just going to go have a little fun, spin some stuff up on Kubernetes, talk about stuff that we found interesting with this, and just kind of, get through it. So without further ado, Josh, if you could reshare your desktop, just leave it shared. When I change off it, it'll stay there. Otherwise, it's a little more challenging.
Sure.
To keep adding it back. There we go. Yeah, just leave it shared. It won't show up unless I add it.
Okay.
So
that's good.
I'm going to jump into Azure Cloud Shell, and I like Azure Cloud Shell because it's a nice, kind of easy to use environment. It's got all my tools. Now, with our start off, so we have an application, the Azure Voting app, that our teammate Paul had rewritten in Rust, and we tweaked a little bit so that we could show off some of the different features inside of Kubernetes. Now, it's a pretty straightforward app. We're gonna spin it up and get to kind of see what's going on with it. But you don't need to know anything really about the app to do any of these exercises. Now, the base repository that we're working off of is in Azure Samples on GitHub. It's the Azure Voting app Rust. And if you are playing along at home, you can fork the repo, but there are branches that give you the end state of what the repo should look like at the end of each day's content. So, if you're trying along with us and you want to check something out, or you just want to, start at a certain day, start at a certain endpoint, you've got those checkpoints there to kind of help you along the way. We're starting out in the, I've cloned down the main branch. Oops, wrong window. There we go. So I'm in the Azure Voting app Rust. I've done a little bit of setup before we started, so we didn't have to wait for spinning up a Kubernetes cluster. There's instructions in the blog post to help set that up. I've also used Azure Container Registry to build our app and store the container image. So we're ready to kind of jump off with deploying our application into Kubernetes. Now, just to show you that there is nothing up my sleeve, we haven't pre-done anything inside of Kubernetes. We'll take a look. Kubernetes get pod. So pods are the basic unit of work inside of Kubernetes. You can think of it, pod, as a container running on a node. So, we can't just use we can't just use like a container instance or something as the naming. We got to give it a different name since we're working in Kubernetes. So we call it a pod. Fair enough. I don't know about you, Josh, but for me, one of the more confusing things about getting started with Kubernetes was figuring out what all of these different terms meant and how they related to other concepts that I was already aware of. So, a lot of this is just kind of figuring out what the right nomenclature is, what the right naming is.
Yeah, mapping it to your existing mental models it's a little bit of a challenge, but it starts to make sense, and you just realize that it's just yet another abstraction and different term for a similar thing.
Yep. Now, thanks to again, kind of thanks to our coworker Paul, he gave us a little tip about how we can actually take some of the kubectl commands and have it give us the output in YAML. So Kubernetes, like it eats and breathes YAML. All of the configuration, all of pretty much everything that goes on with Kubernetes. It likes it'll ingest that YAML. It will spit back out that YAML. Well, we can make that kubectl command help us write some of the YAML that we're going to have to work with. So you don't have to learn this all from scratch. You don't have to leave yourself. You don't have to necessarily memorize all of the different configurations for YAML. Now, the easiest way to get a container going, basically to create a pod inside of Kubernetes, is with the kubectl run command. So the first thing we're going to do is we're going to get our database running. So this app requires a Postgres database, and then we have our web front end. Now, so I've got my container image that's going to pull just right from Docker Hub. I'm going to give it an environment variable, and I'm going to tell it, don't, give me YAML, but run this only locally here. And I'm going to redirect it to a file. Now, the reason I'm doing that is I could just have left off the dry run client and had it apply directly to my Kubernetes cluster. But if I need to maintain this over time, and I'm going to redeploy this thing, a time or two, I'm going to want to have, let's resync that there. I'm going to want to have those manifests handy. So that command generated this for me, right? It specifies out all of the things that Kubernetes is going to want in the YAML file to get this container image up and running. Now, if I ever wanted to go back and change my password, like we're going to do actually a little bit later, actually thanks to the blog post that Josh wrote, how we can extract some of our configuration and secrets from from a file like this and store it in a better way. We'll get to doing that. But all right, so we've got that created. And then we can apply that. So when we create those files, we can, instead of running another kubectl run command, I can just say kubectl apply and give it the path to the file. Now, we're going to make individual YAML files for each of the things that we're doing, each of the individual things. You can put multiple configuration elements inside of one YAML file. So I could model my whole environment in one file. For our purposes here for learning, I like to separate those things out so that we can look at it's a little easier to find the different elements that we want to look at. All right, so kubectl apply says we created a pod. So kubectl get pod. Now we have our database service running. Now I need to run my web application. Now my web application needs to know where my database is. So I'm going to just can't copy paste properly here. So what I need to do is find out what the IP address is of my voting DB pod. Now, let's actually show this. I'm not going to save this to a variable just yet. You can, when you run these commands. So when I ran kubectl get pod, it gave me a nice friendly look, right? I got the name, how many pods are running, what the status is, if they've restarted, and their age. But that's not all of the information that is available. So I can ask it to give me YAML or JSON, um, and it's going to give me a lot more information. Like we just saw a whole lot of stuff just go scrolling on by. And one of the things that I want is the pod IP address. And you can see here, we've got a lot of information about, about our pod. Well, down here at the, kind of one of the last things we saw, we see this pod IP. That's the IP address that I want for my database. I've got one running. I just have one instance to connect to. So that's where this command to let's move that out of the way. Where this command to, or I'm specifying a JSON path. If you're familiar with the Azure CLI, there's a similar query syntax. But I'm basically just indenting in, or indexing in on that JSON and asking it specifically for that pod IP address property that we see right here.
Is that just one way to get away from using grep?
Yep, grep. You could export to JSON and use JQ to filter. Like there's a number of ways. I like when it's actually built into the command line itself, because then there's less dependency on other tools on the machine. But right, like because this will work. This JSON path will work on Windows, regardless of the shell that you're in, on Linux or Mac, regardless of the shell that you're in. You don't have to necessarily have some other tool, some other dependency there, to try to go find that. And because it's structured data, we can index in and find what we're looking for. So
you're saying I shouldn't use regex?
You could treat it like a string and regex your way around, but you know what they say about regex, right? Like you've got one problem, you solve it with regex, now you got two problems.
I've heard that before, yeah.
Yeah. In my experience, that's relatively true. So this shows us that we're getting back the IP that we saw over here, which is what I expect. And I'm going to use that same trick to create the, let's get some more space here. I use that same trick to create my YAML for my Azure voting app. And I'm going to pass in, use a little string interpolation to stick that DB IP that we just got into an environment variable so that my voting app can find its database. And again, we're doing the dry run. Do I have something unclosed? Oh yes, I'm missing a
double quote. Yeah.
There we go. Now things are happy.
Do you have a different ACR name?
Oh, my build tag. I didn't. That didn't save. Let me get that here. I'm going to query my ACR repository to get the build tag from the last build. I didn't specify a tag. I specified the tag to be the run ID. So I don't know it right offhand. So now let's see what the build tag is. Aha, there we go. CA1. All right, now let's try this again. So now we should have a pod app YAML, which is very similar to the one that we just created for the database. It's got two environment variables that we specified. It has my container image, and we can deploy it the same way we did with the database, which was let's which is kubectl. Oh, I am not typing well here.
It usually happens when you get record.
Manifests and pod.app. All right. So if we take a look, let's get my get pods command. Now I have the 2 pods running. Now these things are running inside Kubernetes, and the only networking that is happening is inside the cluster. So if we want to actually see what's going on, we can use some port forwarding to target our front end pod, and try to check it out on our local machine. And as I'm saying that, this is probably not going to work from Cloud Shell. Let me do this here. We're going to pop over here and I'm just going to set up, I'm going to use AZ AKS get credentials to set up my authentication for kubectl to talk to the to the cluster that we're using. So as long as I'm signed in to my Azure account in the right subscription, I give it the resource group where the cluster is and the cluster name, it can set up the set my authentication for me. Yep, I went over it. Yes, thank you. All right. So now let's try that port forward command. All right, so now that the port forwarding is going on, we should be able to go to localhost 8080, and we get our Azure voting app. I can vote for dogs. I can vote for cats. I've actually got 3 cats. Do you have dogs or cats?
I have 1 dog. Yeah.
You have 1 dog. So, yeah. Okay, we got accurate representation there in the Azure voting app. Okay. Let's hop back over here. Let's kill that port forwarding. And we can clean up after ourselves. We'll get rid of those 2 pods. We can use kubectl delete and pass it a manifest, and so it can delete those specific things that are in that manifest. And now if I do a get pod, we're back to clean. Now, pods are cool, but you may have just noticed a little problem. Now, Josh, I'm going to put you on the spot.
Oh boy.
So one of the reasons that we use Kubernetes, right, is to help provide some automation around our workloads, and people may have heard of it as a container blank.
Orchestrator.
Orchestrator is one, or how about something that starts with an S?
Service.
Yeah, scheduler.
Scheduler. Okay. Yes.
Yeah.
Which word? Which word?
Yeah. Yeah. I put you on the spot there. So one of the things here, right, is if we just declare the pods, we're just using Kubernetes kind of as a Docker, kind of like a Docker machine kind of scenario where we're just spinning up containers willy-nilly and not actually giving Kubernetes anything to really help us with. Well, we can use, so the pod's kind of that basic unit of work. Just above that is the concept of a deployment, and the deployment can define the pod. It has the pod has all the information that the pod had, but it tells you how many. It tells Kubernetes to keep a certain number of those pods running, and can give it some other constraints and other information as well. So, right, like if we.
So just to step back a little bit, like the main problem right now with just managing the pods is you don't have an easy way, and this is kind of like the promise of Kubernetes as an orchestrator and a scheduler, is it will handle the scaling. And so is that, like deployment gives you a way to define that on top of just the pod definition. Because right now you've defined, okay, this is what the infrastructure should look like, the image it should be using, the connection to the database and stuff, some configuration specifically. And now we're looking at a level up from that, which would be, okay, now how do we take a higher level look at this and figure out how to deploy it as a set of things?
Yep.
Is that accurate?
Yeah. And right. And what happens when us manually deleting a pod is one thing, but a pod could be in a failing state. And if it's just a pod, it's going to try to restart for a little while, and then it's just going to go into this failed state. If I use the deployment construct, I'm giving instructions. I need this thing running, and so it's going to try some more stuff. And it's going to help. Kubernetes is going to start acting on my behalf, where I've told it my intention, and it's going to figure out the rest of it. Right. And so if you've worked in like a configuration management environment before, or you've ever worked with something like Chef or Puppet or PowerShell desired state configuration or Ansible or Terraform, ARM, those things where you say, hey, here's what I want it to look like, make it so. Kubernetes, the Kubernetes manifests work similarly in that us defining what we want the end state to look like, and then it becomes the cluster orchestrator's job to do the things to get us there. So let's create one of these deployment things. Now, one difference that we have between just going and running a container and creating a deployment is the deployment CLI command. So kubectl create deployment. It doesn't let us pass in environment variables, so we'll have to do a little bit of file editing, which is fine because we're going to use that same trick to export to a file. Now, I want to drop in my environment variable for that. So let's go to our deployment. So now the deployment says it's a deployment, and there's some additional information here, like some labels, a number of replicas, and then we get down to the spec container, and this is information that is much more like what we saw in the pod deployment, because this is basically the pod configuration. Well, we're going to drop in our environment, save that. And now we want to do the same for our application. But let's deploy database, because to deploy our application, we'll need to find out where our pod is running, or what the IP address is for our pod. Now, getting the IP address is annoying, and it doesn't really match kind of the promise of Kubernetes. We're going to get there. There's another set of constructs that we're going to walk through that'll help ease that pain. But so just bear with us for the moment. All right, so we've got that going. So kubectl get pod. Let's see what we got going. We've got a database up and running. Now, if you've been watching, this pod name is a little bit longer than when we created the pod. When we created the pod, it was just Azure Voting DB. Now there's this identifier on at the end. And that's because we didn't specify the pod. We said the type of pod that we wanted created. And so there's some additional random naming bits that get added on to the pod. Now, if you're a Kubernetes expert and random naming bits isn't the right technical explanation, you know what? That's okay. It's good enough for right this moment. So let's create the deployment for our voting app. And then we'll go edit that and get our environment variables. Now, we need to get the IP address for our, before we can go edit, we need to get the IP address for our database. Now, I could do the same command I did before and then come get this name to give it to, Kubernetes get pod and then do my indexing. But I don't know. But if I don't know what this name is, I can use that app selector. So we're going to go here. And remember I mentioned that little bit of data where it said app equals Azure Voting DB. Well, I can pass that in as a selector so it can find the deployment and figure out which pod matches that deployment. And then I can ask by indexing in on the JSON, because there could be one or more of these pods. I just want the first one. That's going to give me my pod IP because I know I'm only deploying one.
Is it kind of equivalent to a tag in VMware and Azure?
Yeah.
The selector.
Yep, very much. So we'll grab that. And now we'll go and take a look at our app deployment. We need to add some environment variables. Let's see, name, we want database server. Value is going to be that IP address that we just got. And we want name database. And we'll do our super secret value of my password. And let's get this one deployed then. All right.
Remember back in the day when we didn't really rely on tags and you just had you've memorized the server prefixes and suffixes and you could kind of guess what the name was. I remember those days.
Yep. When you had your naming standards and that helped you figure out what was where.
Was it was it the RDP box? Was it the web layer? Was it DB? Yeah.
Yep. So let's see. kubectl. And we still actually do have some of that naming convention, right? If we look at our get pods, right, we've got our prefix from what our pod was named before. But now let's try doing that same trick where we get to do some port forwarding. So we can actually go make sure our app is up and running. And let's do a couple. Oh, I don't want to do it here though. I forgot. I got to do that off my local machine. But instead of specifying pod, I'm going to specify deployment. So it knows to look up the deployment, not just a pod, because it wouldn't find the pod with this name. I would have to specify the pod by looking up the pod name first. All right. So let's.
Is that working? Because there's two. Is it still in one deployment? Or is there two deployments? And so is it forwarding like the pods for that deployment to your local port? Is that how that's working?
It picks one. So how port forward works is it will pick one pod from the deployment to forward for you.
Okay.
All right. So now there are things that we can put in front of our pods, like if we were to scale them, so that you get some load balancing and things. We're going to get there really soon, but right now we're just worried about like 1-in-1. So if we do localhost 8080, we're back. Our thing is reset because we have a brand new database in place. But let's get our vote totals back up. And now, so we've got our pods running. Let's kill one of the pods. Let's kill our app. So kube cuddle delete pod.
This is the thing when I first started tinkering with Kubernetes, it blew my mind.
Yeah.
Just this moment right here.
Yep. So we deleted the pod. It told me it was deleted. Let's make sure we pay attention to that name. And now we'll get pods. Look, Azure Voting App, around 11 seconds. And look at that. Different identifier. The same prefix, but the last 5 are different.
And it's kind of hard to put it in context though, because if you look at like what you did, you killed the web part, which is serving the website, the web app. Like that would have been a huge, maybe half-day fire drill had you deleted an IS server that didn't have any state configured. Now, granted, maybe you had some automation, it would be quicker to build, but like say it was one of those servers that you didn't know, like it was just there when you started and it accidentally got deleted in the cleanup. It would be half-day, maybe multi-day fire drill, and having to define a container definition and deploy it out like this, the operator wouldn't even notice, and the customer might not even notice.
Well, and think if this is like an internal app where your monitoring might not be as rigorous, you might not even notice until someone screams that something is down.
Yeah.
Right. Where this is watching all the time and like, okay, hey, that app went away. Let's do something about it. Now we can talk about improving monitoring and different things we can look at there, but this it takes even that little bit off your plate for you, which is nice.
Brings with it new challenges too, so it's not all sunshine and rainbows, but definitely super cool.
So let's see if our port forwarding still works. We may have to, because it was forwarding to the pod that no longer exists. So because it lost connection to the pod, we'll redo that. But but we should still have, because our database didn't change, we should still have our same vote totals. Now, we can kill our web tier and restart that thing all day long. Our data should be just fine because it's all stored in the database. Where things start to go a little wonky is if we kill off the database. Kubernetes will restart it for us, but we've got a couple of problems. It's going to restart it for us, and we might not have the same local storage, and we're definitely not going to have the same IP address. So deployments don't solve all of our problems, but they solve some of our problems, and they queue us up for some other ideas that are in Kubernetes that can help us solve that data persistence and that that unknown IP, that unknown service, that service discovery problem that we have. So, Josh, do you mind if we swap over to you and let you drive for a little while?
Yeah, not at all.
All right. So we'll switch over to your environment here.
Okay, hide the windows. Let's see here.
Yeah.
Pull up Paul's article. How does that look from your perspective, Steve?
I think we're looking all right.
Make that a little bigger. But I want to make sure I touched all the good points that Paul put in here. Maybe he'll join us in any second and rescue me. We'll see. So the main thing where Stephen was running into issues was he had to keep exposing that particular IP from the database over and then forwarding the ports so that you would be able to access them. And so the two things in Kubernetes that allow you to do the same things that deployments did for managing the pods and kind of abstracting that for you are what are called services and ingresses, which is the topic for this next part of the series. So how should we go approach it? Let's just make sure I can see the same thing that you were seeing. Make sure I got all the credentials. So I think you still have the pods up, right? Kit.
Yep. Yeah. The deployments are still out, so we can continue on from this point here. And so you don't have to do this. You don't have to do the setup part of it.
Right. So how we're sharing this is in Azure. I've got access to the subscription and the resource group, and then I use the AZ get credentials command, AZ AKS get credentials to pull the credentials down. And so now I'm able to see the same things that the same pods and the cluster that Stephen was working on. If I were to do a port forwarding here, I'd be able to do that same thing. But instead, what we can do is we can modify the deployments with these services. And so if we look at the manifests for this, so if you notice, Stephen was working off week 2, day 1, and I'm on the week 2, day 2 branch. So if you change to that, you'll see the end state, which is what I've got here, of applying services to the application. And so I think you left off at the deployments, right? So if we just take a look at this should be the same.
Yep.
Okay, so we've got our passwords and all that good stuff. And if we look at deployment DB, it's got the passwords and it's exposing its container port over. So now I guess the first thing would be to look at the services YAMLs so we can see that. So instead of generating them, they're already pre-configured here and we can walk through it. So there's a service on each of the deployments that we want to surface, and the port that we want to surface instead of having to do the port forwarding is this particular service right here, where we're exposing port 8080 of the target. So the voting app has 80 and we want to route it to port 80 of whatever the inputs get hit. Oh, go ahead.
So what does the service do for me?
The service
so like this one's cluster IP. So what this one's what the service does for us, and because the problem we just saw in the last demo, right, was that every time my database gets recreated, it gives me a new IP, and if my app needs to know where my database is, it's always got to figure that out, right? So when we're doing this with VMs or when we're doing this out on the internet, right, we use domain names, right? So that's what DNS helps us with. Well, services help us both with kind of that static IP and not static, but like with some like dynamic DNS and with basically name resolution, and with giving us a single target for things, regardless of how many containers I have behind it. So it gives you a known name to connect to. So what this is going to do, rather than so like if you pull up the service.db for a second.
Service DB, okay.
Yeah. Yep. So before we had to go and target an IP address. We could now change our database server to Azure Voting DB, and and there's a hierarchy of lookups that Kubernetes modifies in your DNS lookups, and it would now find that Azure Voting DB and use that, and that cluster IP then would redirect traffic to one or more of your any of the services that match that app selector, that app Azure Voting DB. So that's what we're So we're basically setting up a load balancer and some DNS.
Right. And so the service on the back end, just to reiterate, so I'm understanding correctly. So this DB services, so the app can talk to the database regardless of pod name, and then we're creating one on top of the app, so that way we can expose it through an ingress. But that way we're not mapping the ingress to a specific pod, but we're to a service.
Correct.
Right. Okay.
Yep. It's a level of abstraction that we put in front. So then no matter where our pods are in this cluster, then we're going to be able to we'll be able to talk to them. We'll have that kind of point, and we would do this internally. Say you were using a SQL Server always on cluster, right? You're going to have a cluster name that everything connects to. And if you were doing if you were doing a load balancing on your web servers, right, you're going to have you're going to target the load balancer, and the load balancer is going to distribute the traffic from there. It's modeling those concepts inside of Kubernetes.
And let's just walk through the syntax quick. So I think that might cement it a little bit, hopefully for me too. So we have the first part is we're defining that it is a service, right? That's just what it is that it's creating the manifest. And then here we have the name. So this is the actual name of the service that's being created.
Yes.
Right. And then we have the spec for it, which is assigning which port. So how do I get to this particular service? So the target port is what the pod is expecting to receive traffic on, which would be 8080 in this case for the web portion of this app. And we want to expose it or be able to access it from the outside coming in on 80.
Correct.
And then through, the TCP protocol. And then the selector is saying, okay, well, what are the pods that are inside of the service or that make up the service? And that's where the selector comes into play, and it's the Azure voting app selector, so it knows which pods to put in this particular group. Okay, and then what about? So this has always confused me a little bit. The type. So it's a cluster IP, meaning that it's internal to the cluster only. This would change if we're going to be creating something else like the ingress, right, where we're trying to get out. Or what are the different types in a service?
So the different service types we have, so we've got cluster IP, that's the default, and that's internal traffic only. Then there's the node port, which is to the node's IP address. So we haven't said node too often. I mentioned it briefly, but the node is basically the VM or the physical machine that that Kubernetes is spinning up our pods on. So it's the container hosts, and you're going to have one or more of those in your cluster. So node port would assign a specific node's IP address so that the base IP address for the machine, for the cluster host, and it can allow traffic outside of the Kubernetes virtual network. There's load balancer, which would allow external traffic in, acting like a cluster IP, but as an external. And then there's external name, which allows us to map to an external DNS name.
Okay.
So the most common one that you're going to spin up is cluster IP. Load balancer is a second. We've got another approach, because what we're going to do is we'll create cluster IP services internally, and then we'll use an ingress to talk to the cluster IP. So the ingress will be a service that's exposed externally and conducts traffic internally, rather than just using the native load balancer and exposing that externally.
Makes sense. Okay, that's a whole lot clearer to me now. So I guess the next thing is, how do we go in applying these manifests? So we've got the deployments out there, and if we look, is it manifests? Yeah.
Yep.
Looking here, we've got this deployed and that deployed and that deployed. So now we have to deploy the services. I don't have to redeploy. I could redeploy all of it if I wanted to, but I don't have to, right?
Yeah. So let's walk through these one by one. So the first thing we'd want to do is put a service in front of our database. So let's apply the service DB YAML.
And so that will use, I call it kubectl. We call it kubectl, right?
Yeah. Yep.
Security disagree. So apply and then file, and we wanted to do the service for the database.
Yeah.
Right.
Pronunciation's hard.
Yeah. I think it's like whatever you first hear and it just sticks. And so for me, that's what it was. Okay. So now that didn't change the pods, but if I use the get service, I can now see that I have Azure Voting DB service, and it has a cluster IP. So this is internal just to the cluster for things inside the cluster to talk to it, which would be the app. Okay.
That's why we see no external IP, right? And the port. Right. So now that we have this, we can go, and it's already updated here, but let's open it up to see let's open up the app, the deployment app. So if we look down now on database server, it's already been replaced, but that was an IP address before. So now we can give it the name of that cluster IP, and we don't ever have to change that again. So, because that's the cluster name for our database server. So no matter which pod which IP spin up to handle our database server, or if we get fancy and do some clustering right on our database server, the app no longer needs to care. It just knows here's the network name to go and uses on my database server.
That's a good mental model. That just clicked for me, just to remember, like, it's essentially DNS, like what you would imagine DNS to be. So that way that you don't have to remember the IP and hard code that into your configs.
Yep, it's DNS with a little bit of with a little bit of like with like a little bit of load balancing internally. It's like, okay, it's this DNS name, and there's these ports that we will allow through for that, right? So now let's reapply the app, the deployment app, so that we get, because right now our deployment app is counting on a specific IP.
Right. So we want deployment app. Do we want to update? I know you had a different image tag. Probably doesn't matter.
Yes. Yeah, we do. Mine's CA1. That will matter because that CA7 doesn't exist.
Oh, it doesn't exist. Well, there we go. Okay, so deployment app. So now the reason why we're running this again is, again, to replace this value here from a hard-coded name or IP to the service.
Yep.
Okay.
And now if we do like a get pods, we'll see that our app just restarted because it just got new environment.
You can tell by the age, right?
Yep.
Okay.
So now
we can do the app service, right?
Yeah. So now that the app has been reconfigured, we can now put a load balancer in front of that, or we can now put a service in front of that. So we're going to do cluster IP because, again, we want to make it accessible no matter how many or whatever different pods are running our voting app.
And we're tired of using the expose command. We want a little bit more resilient way to do that, right? That
what we want the one IP for it to talk to. So when we set the ingress up, we can point the ingress to this service versus an ingress to a bunch of pods.
Because then we'd still have the same issue. We'd be able to access it differently, but we'd still have the same issue. Okay, so we want to apply the service app.
Yep. So now if you do your get service, yeah. So we've now got, and so you could now do a port forward of the service on 80
to get to it from localhost.
Yeah.
Okay.
And again, that you don't have to. But you'd be able to do that, and now you'd be hitting the cluster IP and then routing traffic to one or more pods behind that.
Got it. So now if we take a look at, so now we have the service, right? So and then we have to front end it for something external, that's where the ingress comes into play, right?
Yep.
Okay.
So
it's coming back to me. It's been a little while. Now it's the knowledge is starting to come back a little bit, but I'm glad you're here.
It's all right. So, and we, in the article, if you want to play around with like exposing the load balancer, Paul goes into that, but we can, but we're going to jump right down to, exposing this with an ingress controller. And you can manually do a bunch of that, but we're going to take advantage of the web application routing add-on. So have you ever used the web application routing add-on?
I've not, no.
All right. So we need to enable it for our AKS cluster. So if you could drop to your shell, why don't you, if you scroll down in that, there it is.
Oh, right here. Okay.
Yep. So you'll have to supply the name of the AKS cluster is AKS1. And the resource group is CNNY-week 2.
Okay.
Very creative stuff. You got add-on misspelled. There you go.
That's just a one-time run, and then it's enabled for the cluster.
Yes. Okay. And I believe there's a way to do it with Bicep. I think we might get into that in next week's content. But now the web application routing extension is an accelerator. What it's going to do for us is allow us to get a managed Nginx ingress for us. So that means we don't have to necessarily worry about adding another container that we have to manage and deal with rolling upgrades and stuff like that. It's going to be a hosted managed version of Nginx, which is which is rather convenient.
It reminds me of Snover's talk about the digital transformation. I don't know if you watched that one. I just rewatched it recently. I think it was from Doe's 2018, but he was talking about like why you should take advantage of these types of things because they'll let you move faster. So you could absolutely spin up another container, put Nginx on it, configure the ingress, or you can take advantage of a managed service that does that for you and lets you kind of just install a plugin and hit the ground running.
Yeah, it lets you focus on different things, right? Like, do I want to manage the plumbing or do I want to focus on the applications I'm going to be running? And for some people and in some situations, managing Nginx matters, right? Or managing whatever ingress you choose is going to matter. For others, this, the more bits you can offload, right? Which is why like running AKS is a good thing because you're taking away a bunch of the overhead of managing your AKS cluster or your Kubernetes cluster and letting Azure do that. And right, so there's definitely some benefit in those managed services. And once that finishes up, it takes a little bit to
I guess
to
we
get
could
applied
walk through the ingress a little bit while we wait for that.
Yep. So this is what we're going to apply then after that's enabled. And by giving it that ingress class name in the spec there, that tells it what we're going to be doing, or what Excel, what to do, thanks to that extension that we've added.
And that's called out here, right?
Yep.
So that's how it knows that we're leveraging that.
And then you can see down then in the pathing here, right? We give it a backend. We have to point it to our service and what port we're going to be pointing to there. And
if we pull those side by side, oh, wrong one. We need the service YAML. It's that port there.
Could you stretch that out, maybe full screen?
Oh, sure. Yeah.
There we go. So we can actually,
yeah.
So we're going to point to, the port of the service that's exposed. And because this is Nginx, we can pass in some different path rulings, right? So for certain path segments, we might forward to different services inside of our microservices environment, making it look like one large application, even though it's fronting, and it might be fronting, multiple services. We're keeping it nice and simple here. We've got one app, we got one service, and so
route everything to it.
Route everything to it. Yep.
So the rule is just configuring. So instead of the container and all the different specs and adding that into the deployment or a separate deployment for this, you can really just configure the Nginx routing with this little rule here.
Yep.
That's cool.
And
that's cool.
And if we were going to create an Nginx, our own Nginx ingress, right? We would have to create a deployment for it, and there are definitely some, and actually in our docs, there are walkthroughs for doing just that, and so there's like Helm charts, and we're not getting into Helm charts at all this week, but it's a templated configuration that's maintained by the community for deploying an Nginx environment. This is just much simpler.
I think the one the ingress that I've messed with the most before was traffic.
Yep.
Very similar. So anyway, so we got the add-on in. Now we can, I would imagine had I run this command before, this line would have failed in the deploy.
Yes.
Because it wasn't enabled in the cluster. But now,
correct.
Since it's on, I can apply the ingress. Okay.
And if you do your get service again.
Right out of there.
And now, so we've got our services now. kubectl get ingress, because ingress is a separate thing, right? And so we're waiting for it to get a public IP address. So you can try the command again in a time or two. There we go.
Here comes
so now, yep, you can try hopping over to that IP in your browser.
We still got our data layer.
Yep, because we use the existing deployments, right? And but now our app is talking to our database via the service and not directly.
Yeah, no exposure. I don't need to expose any of the ports, and I can get to it. Anybody could get to it. It's not even local. Awesome.
Yep. So now the database isn't exposed at all, but our front end application is. Cool. And really, I mean, that's a really quick intro to services and ingress. There's a lot more complexity behind the scenes for a lot of these things, but if you're just getting into Kubernetes and you just want to get something up and running and start to play with some of the different settings to see how things go, this is definitely a way to kind of get that started. Now, Josh, can I impose on you to also keep driving for the next section since you wrote that one?
Yeah, absolutely. Here,
all right.
Check out week 3, day 3, right?
Yep.
I need to get back. There we go.
That shouldn't matter.
Is it because I have state changes?
No, it's saying that you don't have that branch. So do a get branch dash all dash all.
Oh, week 3.
So you haven't checked it out yet. Yeah. So
I think I was putting week 3 because that's what I've been working on.
Yeah.
So I was just using the wrong one.
There we go. Now it complains about your changes.
Which I think it was just the.
Yeah.
Oh, I changed this, didn't I? So if we.
That's here's a faster way. Get drop your command line. Git checkout dash and then path to the file that's modified. So dot manifests. So there's a space between the dash.
Manifests deployment app, right?
Yep. Enter.
Just enter.
Yep. So you can see your change went away. Oh. There you go. So that will reset you to the last committed change you had when you were from your.
I learned something about Git every time I'm on a call with you. I tell you. All right, so now we're on week 3. Or
I don't know if that's a good thing, but
it's good for me. It's good for me because I've been stagnant in my Git knowledge for a while. So I always learn a ton. So the next thing, if we look at the next thing we're going to be talking about is with secrets and config maps. So both of
Okay.
these are another resource that you can use in Kubernetes. The whole point of it is to decouple those things, one, configuration, and two, secrets, from your deployments or from your configuration files, your manifests, and put them in something else, a different resource that you can manage. So that way you can have you can keep your deployment the same, and then you can apply different configs as you move through your environments like dev, stage, and production. And then the secrets as well, you can decouple those from the application, and they can change between environment, and you can secure them. So that's what we'll take a look at here. So if we look at the application, I guess we should have stayed on day 2 just to see it, but we'll be able to tell in here. But essentially what I've done with those environment variables, at least the ones, if we take a look at the config map.
Yeah, let's start with the config map. Right.
So here's, do you have something?
So yeah, what is a config map, like conceptually, just like the TLDR on a config
It's
map?
like a key value store for configuration, keys and values that you can store together, and you can it basically moves them away from your configuration, puts them in a different resource, so that way that you can plug them into whatever it is. Now, the config maps, what's interesting about them is there's 2 ways that you can use them. You can use them as environment variables, like here, where you're passing them in. So it's going to mount this to the pod, and these are all going to become environment variables here. But the other way is you could mount it as a volume, and then it would be a file on disk that you would be able to read, your application could read from that way. So that's the 2 ways that you can use a config map. But the real overall purpose of it is to decouple configuration from deployments, and it does that in those 2 ways, either with environment variables or files in a volume.
Awesome. Okay.
Yeah. So here we have the kind. So it's a config map. It's a kind of resource it's going to be deploying, and then in the data is everything that's going to be pulled out. So this was probably new if people aren't familiar with the voting app, but when Paul refactored it, he added in, Steve, you might have added it in, some values for changing what it was. So it's cats and dogs. There's a little bit of a strife on our team with Go and Rust. I'm still the one in the Go camp. Steve's been doing Rust for a long time, and Paul's jumped ship to do Rust as well. And so I thought it'd be fun to put those values in there. And then there's also the database server itself. So I can move that from being hard coded in here, and I can move that even because maybe it changes as we go through environments or something like that. So those are the values that I'm taking out of the deployment and I'm moving into the config map. And they're still going to be shared with the application the same way. And that's why I didn't even need to refactor any of the code I didn't have to learn any Rust, is essentially what I'm saying,
right?
To do this, because it's just going to mount them just like it did before as environment variables.
So that's something I just want to call out. Like if your app reads configuration from a file or takes configuration from environment variables, Kubernetes has a method with config maps to be able to supply that on a on kind of a per environment or per deployment basis, where you can match these things up as you need to for your environments. So you can supply. You don't necessarily have to. You wouldn't have to build a container and bake in certain values to have a test environment or production environment, or like you don't have to bake those things in. There's a way to surface those things natively in Kubernetes.
Well, yeah. So what would happen without config maps? This deploy.app, you would have a different manifest per environment.
Yep.
So now you can decouple that.
Well, unless you needed files, right? And then in that case, that now you're either looking at the next day's content, which is some of the volume mounting,
yep.
or you're baking that stuff into your container image. So yeah. This app takes some configuration via environment, so we're able to work with that here.
Yeah, all depending on the application. So yeah, we'll just get started here. So that's the config map. Inside here is your key and then your value. And then over here, what you can do, I could list this out individually, database, first value, second value. But there's this little trick that you can do from env. And then if you do the config map ref, you can actually pull in all of the values from the config map as environment variables. So because I wanted all of them, I'm just doing that instead of doing one by one. And then you'll notice that I do have still the database as the password, and that'll be moved into, well, it's actually referenced in a secret. I'll get to that in a second. So the first thing we want to do is we'll go ahead and just create the config map. And we'll just apply, let's change back into the manuscripts directory.
You went slip back into author mode there. You said
Sure,
the manuscripts directory.
I did. Manifests directory. Manifests. It starts the same. And I did something with Bash earlier where I was stuck in manuals. I kept saying manuals. Oh, this is a funny little anecdote. I was on a technical writer or training, and I was presenting, and I meant to say Bobby with a different last name. I don't know if they want to be named, but I said I was reading a different book with range, and I said Bobby Fisher. So then everybody started, Bobby Fisher, and anyway, just because things get stuck in my head. So thanks for calling out, Steve.
Yeah.
So kubectl apply, I think it was just config maps. And because it's a completely different resource, it's not going to mess with our current deployment until we redeploy the app.
All right.
I think if we do, is it get config map? Yeah. We've got our config map there. So now if we wanted to, we'll talk about secrets, because then I can go in and apply the secrets. So let's pull that up. So secrets works very similar to the config map, but it's for secrets. Now what I'm doing here is I've done base64 encoding, and then I echoed that out. So you could easily decrypt this. So what you'd want to do is some kind of other encryption tool to put a value in here that only you could decrypt and encrypt. But this works to demonstrate just how this particular secret works. So it's really similar to the config map, except for it's a secret. Do you remember the different types, Stephen? Like why opaque, and that escapes me at the moment.
I don't offhand.
I don't either.
Yeah.
We'll gloss over it. Further research. Yeah. I'll put a note there. Anyway, and then so there's the key value pair down below. So Postgres password, and again, this is just scrambled a little bit. It's the same password as what Steve was passing in plain text, but now I don't have at least that plain text value passed anywhere. Again, in production environments, you want to use a different encryption tool that's not just base64 encoding. So that's the secret. So I can go ahead and create that in the manifests directory. Secret CMO. And there's the kubectl get secrets. Secrets is just one of those words for me that I like somehow always misspell. But what's cool about secrets, I think I put the commands in the post where you can, where's the secrets? Oh, once it's deployed. So we'll wait to deploy, but we can actually get that encrypted value out. So we can see what it would be. Now I've created the config map and I've created the secret, and now I want to modify the deployment to use those. So then when we go back to the website, we should see the visible thing that the user would see is this change from cats and dogs to Go and Rust is the objective. So if we do kubectl, and we're not touching the services, so I shouldn't need to apply any of those. Deployment.
Right. So I did, while you're applying those, I did look up the types of secrets. So there's the opaque secret, which is arbitrary user-defined data.
Okay.
There's service account tokens. There's serialized Docker configs. There's basic auth, SSH auth, TLS, or tokens.
Oh, nice. Okay.
So there's a number there. Now, one of the things too is I know for sure for Azure, and I'm guessing for other platforms, there's integration with other secret stores. So like you can integrate Azure Key Vault as your secret source. So you can use Key Vault to store and rotate and manage your secrets and surface that all in Kubernetes, just like you're using these native secrets.
And then manage identity or workload identity would be the one authenticating the Key Vault.
Yeah. You know what?
I think we should.
Yes. Yeah.
Hopefully, Paul joins us because I know he has an article or he's working on something that uses. He's actually working on writing an article. That's what it is on that exact scenario.
Yeah.
So
if not, we'll get him next week on that.
Yeah.
Yeah.
Okay. So yeah, let's deploy the app. So that redeployed. And then we'll deploy the DB as well. And that's because the database, I did change that deployment as well to use the secret. So it's not pulling it in from a hard-coded environment variable. It's pulling it in from the secret, and then it's, de-encoding that and then using that as a secret that's passed in. So if we use the git pods here, we probably got to update the image tag, don't we?
Yes. And you might have to. You don't have to do that for the database, but
just the app.
Just the app. So you can see the other one's still, the old one's still running because it wasn't able to successfully deploy the new one. So
is that your rollout policy?
Yeah, so we've updated the deployment, but it hasn't been able to be successful, so it can't spin down the other.
So I can reapply.
Yep.
App with a new existing container image. Right.
Yep. And
it's already running.
There we go.
So,
right.
We needed to get the ingress, right? I don't know if I close that tab. Moment of truth.
It's still running.
Oh, look at that.
Now we've got Go and Rust.
Yep, Go and Rust. All right. I think that's it that I had for config maps and secrets.
Cool. All right. So let's so I'll hop over or I'll jump back and make sure that my Cloud Shell isn't shot. One moment here. And yep, my Cloud Shell died. So we'll just go with
Gets good for the win.
I'm going to try to reconnect it here. Let's see. And I'll share this on the stream. So it's going to reconnect the terminal, and I'm just going to get where's VS Code here? Here we go. All right, so let's take a look now. So we've talked about we've got pods, we've got deployments, we've got some config maps in there now and secrets. We have ingress so that we can get at our services. But one of the things we haven't talked about is storage, and especially for the database, we want to make sure that we have. So in my test cluster right now, we have, I think, only one node in the sample, right? So if I scaled out to multiple nodes, I have different ephemeral storage depending on where the cluster decides to put them. And that would not be good for our database. So we want some persistent storage. So let's see what storage providers that we have. Let's say ZKS. Show. Week 2. Query storage profile. It tells me nothing. Why? Did I type something wrong?
Looks right to me.
Yeah. Okay. Well, Paul said we should see some output like this, but
Maybe he ran another command before that.
yeah. All right. So let's try. Let's kubectl get storage class. All right. So here are some storage classes that are baked in to Azure Kubernetes Service. Now, depending on if you're not doing AKS, then you're going to have different storage options available. But we're going to take advantage of these baked in abilities to access Azure Storage and create a persistent volume claim. Right. So we don't need to create the persistent volume because this driver will do some of that for us. So let's.
Well, the mental model for volumes in Kubernetes is really like your database, your data stores in like VMware, right? Where you're going to allocate some storage to this particular thing, and with the name persistent, it's going to stay there, because right now it's just divvying storage for the container, the pod that it needs. And so now you're going to say this is reserved storage that's going to be dedicated for this database, just like when you're going through the GUI of those different tools and you're creating the storage to be able to mount to the VM. Like that's kind of the mental model that I grab a hold of and kind of equate. And so the claim is just you're carving out that space for it to be attached.
Yep. Yeah. You got it. So we will create that claim. Oh, yeah, and I'm. So now if we look, persistent claim, we now have a pending claim. And until one of my nodes, or until one of my my deployments or my pods grabs it, it's going to show as pending. So let's get this attached to our database. I'm going to start by deleting. That's not nice. I'm going to start by deleting our database deployment. And then I'm going to modify that deployment to contain our, here we go. We're going to set up a volume mount. So it's going to map that storage to this particular file path. And I give it a name, and then that name gets referenced on volumes. Right. And the claim name is PVC Azure Disk. I got PVC Azure Disk. So when I reapply this, it'll save it.
I've always thought of it like an auction, with the claims.
Yeah.
The pod's like, hey, I'll take that storage.
Manifests limitdb.camel. Oh, I'm not in the right directory because I restarted my shell. There we go. Now things work better. Now, if we look at that persistent volume claim again, see that it's bound. So what we should be able to do is go take our Azure voting app. Got some votes here. Let's get go a couple more. And now I should be able to pedal get pods. Should be able to delete this pod. Delete pod. And our deployment will restart it. But I should be able to go to my app here. We're just going to make sure that the thing is restarted and talking. It appears to have persisted our... Oh, somebody added... Was that you?
Me. Yeah.
Yeah. Yep. So we'll keep that lead. So our storage was persisted. We restarted the container. It remounted the storage so that our database data was available even after we killed the container.
So when you killed it, if you would have caught or issued the git command to show the persistent storage, it would have gone back to pending, right? And then it would have been back to bound when the container or the pod started.
So let's do that. All right. So let's get our pod name here. So kubectl delete pod. All right. And then and kubectl persistent volume. Now, hopefully the orchestrator isn't fast enough to catch the between, but nope. The orchestrator's fast enough in spinning up the next one that
it doesn't even unclaim it.
Well, it unclaims it, but by the time my command is issued and the API is reflecting it, we're not getting it back. All right, so we're not seeing that, but we would see that our app is still running. It still has its data, and life is good. So between having the internal service to abstract away the IP address and having the persistent storage, we've made our database container or database much more resilient in Kubernetes with two minor changes, right? Now, again, this isn't a production ready app or anything else. So there's a lot more that we would want to do before we kick this thing live to the world. But a few basic constructs really help us as we start to architect out our deployment environment. All right, last but not least, because we've been going for a long time, let's just talk quickly about scaling. All right, that was the last post in our Kubernetes Fundamentals series. And yes, thank you, Defender. Thought I'd turn that off, but I guess not. So we're going to look quickly at scaling pods and scaling nodes, because those are the two things that we want to scale. And we could do this manually. We could issue some commands and tell Kubernetes to, hey, I want 5 replicas of my voting app. And that's great. Kubernetes will respond. Now, if I do my get pods, you can see I've got now 5 instances of my voting app. But that's a manual thing, right? And while it might be like, hey, web server's slow, and so you run over and you scale some of your resources, or you give some more CPU and disk to your database, or whatever. You want to reduce some of those manual interventions. So one of the things that we can do is we can update our pods, our deployment with, let me get the file here. Let's get our app deployment back. Nope. Bring that. We've got our existing configuration that we had before, but now I'm adding in these resource requests and limits. So I'm asking for at least a quarter of a CPU and at most half a CPU. And the reason I'm putting some limits on here is so that we can tell Kubernetes to monitor that CPU utilization. You could do memory limits too. And then I can give it some guidance on scaling. And you can't do that unless you define these limits. The docs will have, kind of what the different numbers map to in terms of actual system resources. But once we do this, so let's apply this change. So kubectl apply. Manifests deployment app. Now I can tell it to configure auto scaling. And let's just see what that configuration would look like. I'm going to say kubectl auto scale deployment. Which deployment? The Azure Voting App one. When the average CPU utilization across its containers is above 50%, and I want to have at least 3 containers and at most 10. And let's get what the YAML would look like for that.
It gives you some crazy capabilities, because if you think about it, traditionally, what happens is you hit capacity at some peak time and you add capacity, and then that capacity just stays.
Yeah. And your expenses stay, right?
Right.
Now, one of the things about so we've got the scaler up. So let's take a look at what our pods look like now. Now we're down to 2. And now we've got a few others that are spinning back up. What the autoscaler is going to do is every 15 seconds, it's checking the metrics API for those containers. Now, the pod stats are only updated every minute. So roughly every minute, there could be a scaling event. Now, once there's a scaling event, once it scales down, there's a cooldown period to let kind of that workload settle out. So if it knocks my number of containers down, you'll have I think it's a 5-minute window. Then there's no delay on a scale up event. So that is setting up scaling for our apps. Let's see where we landed here. So we've got 2 and 2 possibles. Now, these pending ones are because system resources. Right now, I only have 1 node. So there's probably not enough between the database and these apps to guarantee that there's resources to start these things. So let's scale our nodes. So we can do that manually. And I can just do AZ. Now, to scale my nodes, because I'm working in Azure, I'm going to be using some Azure commands. Resource group. Week 2. Name AKS1. Let's go to 3 nodes. Now, this might take a minute because it's going to spin up a couple. So in Azure Kubernetes Service, AKS, we're using VM scale sets for our node pools. Depending on where and how you're running Kubernetes, you might not be able to dynamically extend them, or you might have to deploy some physical hardware or provision some new VMs. There's going to be different capabilities around, but you can, manually add nodes. But then there's a cluster autoscaler, and the cluster autoscaler takes a look at, hey, you've asked me for a certain number of pods. I don't have the resources on the current number of nodes. I'm going to have to scale up, or I'm going to have to scale down. And so we could use the cluster autoscaler to be able to, similar to how we use the autoscaler to scale out our pods, to scale out our nodes. So we'll let this thing run and just kind of start to wrap up because we've been going for an hour and a half here, and there's probably lots of other things that y'all could be doing. So let's. Now, there are other things. So the autoscaler really works against the metrics API, against CPU and memory utilization. There are other things that we might want to scale on. And for that, there's projects like KEDA, which is the Kubernetes event-driven autoscaling project. And there's a whole lot of different plugins that you can use to scale on different cloud events, on different like HTTP requests, on stuff in the queues. There's all sorts of different scalers that you can plug in, and so you can definitely play around with those things. This is the basic. What we just covered was the basic stuff that's built right into Kubernetes that you can use in just about any Kubernetes cluster that's out there. With some of the little niceties that you have on Azure as well. But anything that we're forgetting, Josh?
I think that covers it from the topics, but I mean, what we just covered here will give you a really good fundamental. It gives you all the tools to really kind of like anchor your previous knowledge into the Kubernetes world, because there's a lot of new terms, there's a lot of new different components and pieces and abstractions. But all these things that we walk through in this 90 minutes is really kind of the foundation that will get you familiar and able to use it and able to deploy apps on there. And the one thing that kind of hung me up was like, well, I don't have an app to deploy. That's why you grab the sample app and save yourself having to write all that and just figure out all these things like scaling and decoupling the secrets, because that's where, at least for me, people that have the operation background can really dig in and get a handle on Kubernetes, at least from like the fundamental knowledge layer. So I would just encourage them to walk through the branches. I liked how we laid it out, where you can just check it out and that's the state, and you can see the difference between day and day of the different fundamentals that we covered. So yeah, I would just say dive in and walk through the code.
Yep. And if you haven't, right, hop over to Cloud Native New Year, aka .ms. /CNNY. That takes you, it takes you to our, Cloud Native New Year. You can jump on over to the blog, walk through all the stuff that we just talked about in the week 2 content. Next week, we're going to take and apply these things to a more line of business style app. So something that wasn't designed to be running in Kubernetes, something that wasn't necessarily designed to run in a container. And then we're going to apply this and some more stuff like secure supply chain topics and debugging your app while it's running in Kubernetes. Basically, how do I start taking the stuff that I'm currently working with and make that work in Kubernetes? So we're going to work on that next week, and we'll be back next week on Friday to do a little walkthrough again of all of that. So, did I actually share my screen? See, I did not do that because I'm in charge of doing that, but I have not yet done that. It's
Practice makes perfect.
Yeah.
It'll be better next time.
So the thing I was sharing was, let's do this here. Was our set of blog posts. We just finished talking about that. But go from pods and deployments, services, ingress, config maps, volumes, scaling pods and nodes, and then starting next week, we move into those other topics with an existing line of business app. So join us for that. Hop over, check out the blog posts, and Josh, thanks for taking the time here to hang out with me and run through some of these demos and ask some good questions and help make sure I didn't miss stuff. So,
it's my pleasure. My pleasure.
All right. With that, we are going to be out. All right.